This video is on revolving about other axes than the primary x and primary y-axes. So same information is going to be given. You're going to be given a region bounded by, and we'll look at an example. So this region for problem number 57 is bounded by the parabola y equals x squared and the line y equals 4 and x equals 0. And we're going to revolve around y equals -2. So we need to go back to the definition of what a washer method is. And with the washer method, you are looking at finding the area of the outer circle and subtracting off the area of the inner circle. So the volume for a solid of revolution using the washer method is pi times f of x squared minus g of x. G of x squared. And here what you want to remember is that f of x is the outer radius r and g of x is the inner radius little r. And then you integrate with respect to x in this case. So let's draw out this problem first and look at the region that we're revolving about, the line y equals -2, and that's the parabola. And here's the y equals 4 line. And you're bound by x equals 0. So you're looking at this region here. And then I'm going to draw in the line that we're going to be revolving about is y equals -2. So now we're essentially revolving about the x-axis, but we're shifted down 2 units. So this is essentially revolving about x, but we're shifted down. So we have to account for that shift in our radius. We're shifted down, we're shifted 2 units down. So let's go back and return to the volume using the washer method. And the volume, we're going to integrate from x equals 0, and this point is x equals 2. So we're going to be going from 0 to 2, and the formula is the outer r. So let's look at the outer r. Well, the outer and the inner r, if we're revolving about -2, the outer r is going to be the radius of this length, and the inner r is going to be the radius of that length. So that's little r and big R. So big R is 4 units plus the 2 that's down below the x-axis. So this is 2 plus 4 for big R. And little r is just 2 plus x squared. Right? So you've got this inner and outer radius that you need to account for. So this is actually how the integral is going to be set up using the washer method when you're shifted about off the major axes. So this is just algebraically working through this problem now. I'm going to pull the pi out, and I have the work done in front of me so that I can speed up this video. Scroll down here a little bit. Take the antiderivative and clean this up algebraically. Oops. this is x to the fourth minus 4x squared dx, and taking the antiderivative, you're left with 32x minus x to the fifth over 5 minus 4x cubed over 3. And you want to evaluate that between 0 and 2. And if I did all of my mathematics correctly, my arithmetic rather, substitute here, and then of course this lower limit is just 0. And you're timesing that by pi, and I got 64 minus 32 fifths minus 32 thirds, and if I find a common denominator of 15, I end up with 960 fifteenths minus 96 fifteenths minus 160 fifteenths, and I did get the correct answer on this problem. It's 704 over 15. So you can see what happened with shifting off the major axis of, in this case, the x-axis. We went down 2 and it changed the radius of the problems, the inner and the outer radii. Well, just briefly, I want to go through another one. I'm not going to walk all the way through the problem, but what would happen if you had a diagram that looked like this? So here's your area of interest, and perhaps you want to revolve around y equals 2. So in this case, you again would have to define your outer and your inner radii. But now, because the line of revolution is on top of the function, now this thing is going to look a little bit different. But if you will, this distance is 2. But this outer and inner radius, and here's your inner, and here's your outer. So the outer radius is actually going to be 2 minus f of x, whatever that function is. 2 minus f of x squared. I'm going to call this f of x for now. And I'll call this g of x. Right? But the outer function, if this is 2, and this distance is f of x, right, this distance, grab another pen, then this distance, which is your outer radius, or your big R, is going to be this minus this. And similarly, for the inner radius, you're going to have 2 minus the function g of x squared dx for the same reason. Let's see if I can grab another color here. This distance again is 2, and the distance to g of x is here, and this distance minus this distance is going to give us this inner radius. So that's the setup for a situation where the axis of revolution is above the area that you're used to seeing. So the bottom line here is that you will have to, depending upon the problem that you're given, you will have to sit down and figure out what your radius of the outer and the inner circles are how they're going to change based on the shift. Okay? So just remember, you're finding, to summarize, you're finding big R and little r based upon another axis, or a non-major axis, based upon revolving about another axis. about something other than X or Y. Hope that helps.